Hello everyone, my name is Subham Mahto, and in this video we will discuss about Weierstrass inequality. So this inequality is given by a German mathematician named Karl Weierstrass. So what this inequality states, for for any real number x1, x2 up to xn. It means we have n number of real numbers. Now if these real numbers are greater than equal to 0, that is if xi is greater than equal to 0 for all I between 1 to n, then this real number will satisfy the inequality 1 plus x1 product 1 plus x2 product 1 plus x3 up to 1 plus xn. So this product will be greater than equal to 1 plus x1 plus x2 plus x3 plus up to xn. So this is the one of the inequality. Now the second equality is for the condition of xi should be less than 1 and greater than equal to 0 for all I between 1 to n. Then it will satisfy the inequality as 1 minus x1 1 minus x2 product 1 minus x3 up to 1 minus xn. Now this product will be greater than equal to 1 minus x1 minus x2 minus x3 minus up to minus xn. So these are the two inequalities given by Karl Weierstrass. Now for better understanding, we will take one particular example. So example I am taking. So suppose my x1 is equal to 1, x2 is equal to 2 and x3 I am taking 3. So for the first example, if we see 1 plus x1 product 1 plus x2 plus 1 plus x3. So this product will be equal to 1 plus 1 is 2 because x1 value is 1. Product 1 plus 2 is 3 and product 1 plus 3 is 4. So this will be equal to 24. Now if you see the value of 1 plus x1 plus x2 plus x3, then this will be equal to 1 plus 2 plus 3 plus 4, and that is equal to 4 plus 3 7, 7 and 3 10. So clearly this 1 plus x1, 1 plus x2, 1 plus x3 is greater than equal to 1 plus x1 plus x2 plus x3, right? Now for the second part, x1 equal to 1 upon 2, x2 equal to 1 upon 3 and x3 I am taking 1 upon 4. Then the product 1 minus x1, 1 minus x2, 1 minus x3, this will be equal to 1 minus half, 1 minus 1/3 and 1 minus 1/4. So this will be equal to half product 2 upon 3 product 3 upon 4, and this will be equal to 1 upon 4. Now if I take this sum, that is 1 minus x1 minus x2 minus x3, so this will be equal to 1 minus half minus 1/3 minus 1/4, and that is equal to half minus 1/3 minus 1/4. So if we solve, then this will become minus 1 by 12. So clearly here 1 minus x1, 1 minus x2, 1 minus x3 product is greater than equal to 1 minus x1 minus x2 minus x3. So this is one example for both cases, right? Now we will see the proof of these two inequality. So now we will move for the proof. So I will prove for the first one. So the given condition is this xi's are greater than equal to 0 for all I between 1 to n. So see, if you write the left part, then it will be 1 plus x1, 1 plus x2 up to 1 plus xn. So if you multiply the terms, then what will come? It will be 1 into 1 into 1. So one term will be 1. Now see, if this x1 will multiply with 1 and it will multiply up to this 1, then it will come x1. Now if this 1 will multiply with x2 and this x2 will multiply with 1 with every factor, then it will come x2, and like that we will get up to xn. Then we will get x1, x2 and many more things we will get, right? Clearly this x1, x2, x3, these all are positive number. So addition of positive number and multiplication will give you positive. So see this, after xn all the terms are positive, right? So this will be greater than equal to 1 plus x1 plus x2 plus up to xn. So hope you understood the first proof, right? Now see what idea I used here. Suppose you have a number a greater than equal to 0. Then if you add something on both sides of the inequality will. So here my x is 1 plus x1 plus up to xn. And this a is my this positive number. So clearly it will be greater than equal to x, that is this one. For the proof of second inequality, I will use mathematical induction. So here my condition in xi is that these are less than 1 and greater than equal to 0 for all I between 1 to n. So see, if I take n equal to 1, means we have only one number, that is x1. 1 minus x1 will be greater than equal to 1 minus x1. So it is true for n equal to 1. Now suppose it is true for n equal to k. That means 1 minus x1 product up to 1 minus xk will be greater than equal to 1 minus x1 minus up to xk. See, this is true for n equal to 1 and we are assuming that it is true for n equal to k also. Now if I am able to show that this is true for n equal to k plus 1 also, then by mathematical induction it is true for every natural number. So for n equal to, for n equal to k plus 1, we have 1 minus x1, 1 minus x2 up to 1 minus xk plus 1. This can be written as 1 minus xk plus 1 and product 1 minus x1 up to 1 minus xk. Now see, this product will be greater than equal to 1 minus xk plus 1 and this side will be replaced by 1 minus x1 minus x2 minus x3 up to xk, right? Now see, if you multiply these two factor, then 1 will be multiplied with each of this term. So you will get 1 minus x1 minus x2 minus up to minus xk. And when this minus xk plus 1 will multiply with 1, then you will get minus xk plus 1. After that, this minus xk plus 1 will multiply with each minus xi, then that will give you plus x1 xk plus 1, right, up to xk plus 1. Now see, these are nothing but positive term because these xi's are between 0 to 1, so this product will be positive, and hence this will be greater than equal to 1 minus x1 minus x2 minus up to minus xk plus 1. So this is true for k plus 1 also. Hence, by induction or mathematical induction, we can say this 1 plus 1 minus x1 product 1 minus x2 product up to 1 minus xn will be greater than equal to 1 minus x1 minus x2 minus up to minus xn for all n belongs to natural number. Means for any number of real number we can say these things. So this is the inequality that I want to explain today, and these are the proofs. So hope you understand these things. So for today this is enough. So we will meet in the next video where we will discuss good problems. So for now I want to say thanks for watching my videos, and if you like them please subscribe. So for now, bye bye.